Easy to tell asteroids and comets apart. Asteroids are solid lumps of rock and metal, capable of careering into planets and killing dinosaurs. You typically find them in the inner solar system, particularly in the asteroid belt between Mars and Jupiter. Comets, on the other hand, are icy bodies that form on the outskirts of the solar system. On their rare forays towards the Sun, their frozen bodies react with solar radiation to create spectacular tails. An object known as the Elst-Pizarro, however, refuses to be so neatly pigeon-holed. When it was first discovered in 1979, its orbit in the asteroid belt led to it being classified as an asteroid. Yet, when it was examined more closely in 1996, it showed itself to have a tail, similar to a comet. Astronomers first thought that the tail was debris from a collision rather than something bestowed by the sun's heat. But the tail's brightness and structure changed over time, pointing to an ongoing process rather than just a one-off event. The object's rapid rotation, completing a full spin in just 3.5 hours, also pointed at comet. One possibility, however, is that a collision has exposed some subsurface ice on the body, which is slowly being lost to space. In this case, Elst-Pizarro would be an asteroid masquerading as a comet until it has shed all of its exposed ice and gone back to being a standard asteroid again. We humans love to categorize things. We use mental boxes, labels, and compartments to make sense of nature. Usually this isn't a problem. A galaxy is not a moon and a comet is not a planet. Woody Allen once spoke of a mythological creature that had the head of a lion and the body of a lion, though not the same lion. We laugh because we know exactly how animals are sorted out, or even actual asteroids for that matter. This explains why astronomers are so nonplussed by the Elst-Pizarro object, discovered in 1979, that seems to be both a comet and an asteroid. In real life, as mentioned before, a comet and an asteroid are very different. Comets are chunks of ice in water a few miles wide with dusty debris mixed in. This is why the late American astronomer Fred Whipple famously called them dirty snowballs. They mostly live far beyond Pluto, in either the Kuiper belt or the more distant Oort cloud. Gravitational interactions periodically send a few comets inward towards the Sun, where the gravity of Jupiter or other planets alters their orbits. Their highly elliptical paths carry them close enough to the Sun to gradually destroy the ice. Since ice cannot melt into liquid form in the vacuum of space, it turns directly into vapor, a process called sublimation. This gas, along with tiny solids freed when the ice sublimates, gets pushed away from the Sun by our star's solar wind of fast-moving particles. Voila, a tail, every comet's most photogenic feature. Each time the comet passes perihelion, which is its nearest point to the Sun, it loses more of its ice. Such continual mass loss eventually destroys every comet, which is why it's so hard for them to get insurance. An asteroid is another whole beast altogether. It is a chunk of rock and not ice. It can be piano-sized or even 600 miles across. Asteroids are left over from the solar system's birth, the debris that never glommed together to form an entire solid planet, thanks to the fierce Jovian gravity near where they orbit, just inward of that giant world. Meteorites, which are pieces of stone or metal that reach our planet's surface, are almost always asteroid fragments. In contrast, nobody can ever hand you a comet chunk. They whiz right through the sky to create meteor showers, but their fragile ice never survives the trip through our atmosphere. So as you can see, comets and asteroids are completely different. So this explains why nobody paid much attention to asteroid number 7968, now named the Elst-Pizarro, which lives in the main asteroid belt between Mars and Jupiter. Nobody, that is, until the object approached its orbital perihelion in 1996. That is when photos taken by Eric W. Elst and Guido Pizarro clearly revealed that it had a comet's tail. But asteroids are rocky. Things don't flake off them. What could this tail be possibly composed of? During its next perihelion passage in late 2001, the cometary tail materialized once again and lasted for months. Was this a comet that had somehow wandered into the wrong place, like a child raised by wolves? Arguments still rage between astronomers. To settle them once and for all, space scientists had hoped to launch the Castalia spacecraft for a closer look in 2028. However, the mission failed to get the green light in the European Space Agency's 2016 round of funding. So, the disagreements continue, for now at least. So interesting, yes? If you like this video, leave a like